Hello everyone. Welcome back to another session on SQL. So today is our day 10. So let's look at what we are going to cover in today's session. Okay. So in this session, we will be focusing on performing complex row by row comparisons, generating financial subtotals dynamically, ranking data, and writing clean professional T-SQL scripts. Okay, and mostly we will cover window functions and CTEs. Okay, so I'll come to that one. Okay. Now, first is window function. Okay, so the concept of the window function is like over and partition by. So we can use over and partition by. So basically, when it comes to standard group by, so what happens? It collapses your data. So if you group by department or any other field on total salary or any other measure, so you lose the individual employee names, right? So a window function basically using over clause allows you to perform an aggregation without collapsing the rows. And then we can also use partition by, which kind of resets the calculation for each category, acting like a localized group by that appends the result to every single row. Okay. Apart from that, we will also cover row number, then rank, dense rank, and entile, and which basically divides the result into specific number of equal groups, and entile 4, so which is basically like creates quartiles, sorting your data into the top 25%, bottom 25%. Okay. Now, apart from that, we will also look at time series analysis like lag and lead functions, which looks backwards at the previous row, crucial for calculating month over month or year over year. Okay. And then on the opposite hand, so lead function basically looks forward at a subsequent row. Apart from that, we will do some dynamic subtotals like ROLLUP. So adding with ROLLUP to a group by clause automatically generates subtotals for your hierarchical data plus a grand total at the bottom. It is a massive time saver when it comes to financial reporting. And then CTEs or common table expressions using the with clause. A CT acts as a temporary table. So basically, when it comes to views, it acts as a it is physically available. You can query on it. But with common table expressions, you can wrap up a function, create like a temporary table. But the availability of that particular table, as it says, is temporary. Okay. So it will not host your data forever. I mean, host the data forever. But yeah, on the run, if you want to create a table and then use and reuse that particular table, you can use CTs. Then apart from that, we will also see some error handling by using try and catch. So instead of script crashing halfway through the code and leaving the data in a corrupt and vulnerable state, we can use try and catch, which gracefully catches the error, allows you to log it, and then also safely stops the execution. Okay, now let's get started. Okay, the very first example, as we have been doing, so we will create a database. We'll call it as date and demo, and then let's point to this particular database. Again, so since it's not pointing, let me just point it out. Okay, so now we are in the database that we had just created, date and demo. So in this particular database, so the very first thing that we will do is basically we'll create a table. We'll create a table called sale ID, region, salesperson, sale month, and revenue. Okay. Now, if you're executing, so our table is created. Okay, so our table is empty right now. If I want to insert some values, I can insert these records. Okay. Okay, so now I have inserted 7 records. So now if I just go ahead and do a select star from regional sales. Okay, so I get the table with the values. Now, next, our scenario is we want to use some window functions. The very first function we'll try is over and partition by. So if our goal is, so now you can see the data. Okay, so if we are trying to show each salesperson's revenue, but also show the total revenue of their entire region on the same row. Okay, I want to see the total, the revenue of the salesperson. Okay, and the total revenue of their region, entire region. Okay, not just their region, their entire region. Like for example, if you see the revenue for Alice and total revenue for North, since Alice is in North, and total revenue for North. Okay, so first we have to use select region salesperson revenue. Okay, then we have to use sum of revenue. If you're just using sum of revenue, then it will give us total revenue, and then we have to also do a group by, right? But here using over and partition by, okay, using over and partition by, we'll use sum of revenue over partition by region, because we want to distribute it by region, right? So now we are looking at sum partition by region. So for this particular column, I will name it as total regional revenue. Okay. Next, I want revenue divided by sum of revenue over partition by region. Okay. So this total divided by total revenue divided by revenue for a particular region. Okay, total revenue divided by total revenue for over a particular region. Okay, now I'm also multiplying it by 100 as, and I'm providing an alias name called as percentage of region. Okay, so now if you go ahead and execute, so now if you can see what we are getting here is region, salesperson, revenue. Okay, and then we are also getting total revenue. Okay, so now you see, since there are multiple salesperson, the revenue is also for the entire region. Like for example, North. So the revenue is for North. Okay. Now if we keep scrolling down, we'll see the revenue for South as well. Okay. So for North and South, it has, we have done a sum and then we have partitioned by region. It means just like we are doing group, sum of group. So basically it's summing up, but for specific groups. So here it is summing up, and then as the name suggests, it is partitioned or divided by region. Okay. So for North, every time North comes, the total revenue for North is this. The total revenue for South is 39,500. Okay. Now, next column is basically revenue divided by sum of revenue over partition by region. Okay. So revenue divided by sum of revenue. So it is revenue, this value, total revenue. So it is basically revenue divided by sum of revenue over partition by into 100. Okay. Then we are getting this particular value. Okay. Now, next example is ranking. So basically what happens if I want to find out uh, which particular I mean, what is the rank of a particular individual or salesperson in the overall? Okay, overall, what is the rank? Like if someone is one, rank one, if someone has done the highest amount of sales, then the second highest, then the third highest. If I want to find out, I can assign a rank. Okay, and then I mean I can assign a row number, and then from the row number, basically, I can extract or use that row number, or else I can also assign rank, and then I can use and reuse the rank as well. Okay. Now, the very first example is, we'll do select salesperson revenue and then row number. So row number will basically give us a sequential row number. Okay. It will just create a column which will give the row number on the basis of revenue as row number. Okay. Next is rank. Again, ordered by revenue descending. Okay. As standard rank. Okay. If you see, there will be some values which will have what do you call it, which will have repeated values like 15,000. Bob has 15,000, right? So it will be a tie. Then two persons will be or two rows will have rank 2 and rank 2. Okay. In that particular scenario, we can also use dense rank. So dense rank, as the name suggests, if there is a tie between two rows, it will just give the first row as one number and the second row as the next number, and accordingly. Okay. And then if I want to split all rows into two equal buckets, like top half versus bottom half, I can use entile 2, and then again I want to do it on the basis of revenue, so top and bottom. Okay. So now let me just execute and show you the output. Okay. Now you can see for row number, so I can directly see 1, 2, 3, 4, 5. So all the row numbers I can see. Okay. When it comes to rank, standard rank, since there are two values which were repeating, that's why when it comes to standard rank, the values will repeat. So 1, 2, again 2, and then since it's the fourth value, it will show a fourth value, and then 5, 6, 7. Okay. My mistake. So dense rank basically will not directly start from, it's the other way around. So if there are two values which are 2, then the next value will become 3. Okay. So 1, 2, so two values are ranked as 2, and then the third value or from the top, which will be a third value. So that will be ranked as number 3, then 4, then 5, then 6. Okay. And then entire value is dividing the entire revenue into two buckets. Okay. One will be the top and second will be the bottom. So we have here two values. So 1, 2, 1, 1, 1. All these are the top buckets, and the bottom ones will be the bottom buckets. Okay. Now, next, lead and lag. So the scenario for lead lag is, let me go through the scenario first. Okay. Now, so this is lead and lag, both are time series comparisons. So imagine, or the goal to use lead and lag is, if I want to compare two rows. Okay. Like for example, I'm having in one row, I'm having Alice, and in the second row, I'm having Charlie's February sales. Okay. So I want to compare Alice and Charlie's February sales to their January sales. Okay. If I want to compare, then I can use lead and lag. Okay. So how do you do it? So select salesperson, sale month, revenue as current month revenue. Now, if I want to compare the previous value, I can use a lag. Okay. Lag revenue 1, 0. Okay. Which will look at the previous value. Okay. And then it will look incremented by one number. Okay. From the same, it will go one number. So what happens here? So it will look back one row, ordered chronologically and partitioned so that we don't mix Alice and Alice's data with Bob's. Okay. Next is lead. So lead revenue 1, 0 over partition by sales person and order by sales month as next month revenue. Okay. So if I want to look at previous month revenue, I can use lag. And if I want to look at next month revenue, I would use lead. Okay. Now, just see, I want to see revenue, how I'm partitioning. I'm partitioning by sales month, and then I'm ordering by sales partitioning by salesperson and ordering by sale month. Okay. Now let's go ahead and take a look at the output. Okay. So now we see current month. Okay. Now, what is the previous month? Since Alice is not having any value for the previous month, so it's showing 0. Okay. Whereas if you see next month for Alice, in January it was 10,000. For February, it is 12,000. So it's giving me February 12,000. Since I'm partitioning by sales, so it's only looking at, it's grouping by sales and then it's doing the lag. Okay. Same way, if it's doing the lag and lead both. Okay. Same way, if we look at Bob. Okay. Now, if we look at Bob, so for Bob, previous month again 0. Next month is 15,000. Since both are same, so we're getting the same value. Now for Charlie again 8,000, 9,500. The previous month 0, 9,500, and for Charlie February month, previous month is 8,000, and we don't have Jan Feb March data, right? So that why we are not looking out, it's not showing March data. So since Diane had only 1 month, that's why for the previous month it's showing 0, and for the upcoming month it is also showing 0. Okay. So what I would recommend, you practice this lead and lag. This is very important if you're going for interviews on SQL. So this becomes very handy. So make sure you are practicing this lead and lead multiple times on multiple scenarios. Okay. Now, next we'll look at group by ROLLUP. Okay. Now, if I want to get total revenue by region, then by salesperson with automated totals and a grand total. Okay, so that's when we can use ROLLUP. Okay, so I want to find total revenue by region and then by salesperson, and I want to also see automated subtotals and grand total as well. So together. Okay, so if I want to do that, so first we'll do select, then coalesce region. Okay, and we'll provide a name as grand total as region. So this is very basic. And then again, we'll use, so we can use coalesce basically, as I told you, to replace the nulls generated by ROLLUP with readable text. Okay, so the next, if there are null values, the first value that will appear, okay, in the null records, it will coalesce will capture that. Okay, now coalesce salesperson region subtotal as salesperson, and then we have sum of revenue as total revenue. Okay, now when we are grouping by ROLLUP, we are rolling up on region and salesperson. Okay, now if we go ahead and execute. Okay, so for region North, Alice, total revenue is this. For Bob, this is total revenue. Then we are getting region subtotal. Okay, this is giving me region subtotal. And then once we are getting Charlie, then we are getting this 17. Then again for South, we are getting region subtotal. And then finally, we are getting this grand total. Okay, so this is how ROLLUP works. So it will basically give you total and then subtotal and grand total as well. Okay. Now for common table expressions. Okay. Now, if I want to find the month over month growth, but only show records where growth was positive. Okay. Ideally, you cannot put window functions in a where clause directly. So we have to wrap it up. First, we have to apply the CTE, and then we have to apply the window functions. Okay. Now, okay. First, this is the CTE. Okay. So with month over month. So this is the table that we are creating. This is the table as this is how the syntax works. With provide a temporary table name as select salesperson, sales month revenue, lag revenue 1 over partition by salesperson order by. So if some value is missing, then it will give you the revenue. Okay, salesperson, order by sale month as revenue. So if I just go ahead and run this query, okay, so this is the output I'm getting. Okay, because previous month somewhere it will not be present in some cases, not in some cases, almost like half of the cases. Okay, and the previous month will not be present, right? So wherever it's January, the previous month records will not be present because we don't have 2024 December data. Now, then just like we were doing view, so it is a similar syntax as view. So, but we are using with table name as, then we are keeping the entire query within this bracket. Okay, now we have created the query. Now we can directly run, since we have created this table month over month data. So I can do select salesperson, sales month, and then revenue minus previous revenue. Okay, revenue minus previous revenue as growth over month. And if revenue and previous revenue difference is 0, then it's then it will, it will only show where revenue and previous revenue difference is greater than 0. So if I want to execute, so I have to execute the entire query. Okay, and this table that you will get, since it is different from view, because once you create a view, that will have its existence, right? So you can't keep, you don't have to keep creating. But here it is, every time you are running a query, you have to run it with the temporary table that you have created. Okay, so now this is how it works. If I just go ahead and execute this, I'll get an error because it will not identify month over month table. There is no month over month table unless I include in my query this part, which creates this temporary month over month table. Okay, so this is how CTO. Now there'll be a question like, why, if we can create view, why do we have to create the CTs? See, when if there is a requirement for 10 views, okay, so do we have to always keep creating view? So there will be scenarios where that will occupy more data, it will take more resources. So rather than doing it, so what we are doing here, on the fly we are creating a temporary table, and once the query has been executed, the existence of this particular table will be gone. It's like a variable that you create in any programming language, and after creating a variable, you use those variable, and then once you abort the code, the variable will not have any existence, physical existence. Okay, it's something similar. So this one is like a variable or a temporary table that you're creating while executing the query. Now, if I want to capture some errors, okay, and I want to safely handle divided by 0. So earlier in our videos, just take a look at it. Like we had used if null, then convert it to null. Okay, if the value is 0, then convert it to null. So we had used that particular scenario. Just take a look at it. Okay, here if we want to handle, okay, it can be anything. You can handle any errors, but yeah, so this is a specific scenario where if divided by 0 error occurs, the script should not crash. Okay, so what we are doing, so begin try, so this is the syntax. So where we're declaring two variables, 10, and then another second variable is basically int num divided by 10. Okay, this result is an integer, and at the rate num, okay, this variable divided by 10. Okay, so if we have to make sure this does not break. Okay, and then we have to print, this line will never print because error skips to the catch block. Okay, now and try. Okay, so now if we do that, now once the try has ended, then we can begin. We can use catch, select whatever error number as error number, and then we can, even if you want to insert, so insert into select, if you want to use, you can also do that to create a log table and capture all the log errors that you have. Okay. Now, for now, I'm just going to display this. Okay. So now if I go ahead and execute, okay, so now since there was an error, so this is the error number, and then divided by 0 error encountered, and then uh, line causing error is line number 4. So 1, 2, 3, 4. So this is the line. Since this has divided by 0, so this is the line which is causing the error. Okay, so basically with this, we will end this session, and thank you so much for coming this far and watching all the videos. I would really appreciate if you can comment and provide me feedback. Thank you so much. Have a nice day. Thank you.